Welcome to this high-yield finals prep explainer. Today, we're putting you directly in the driver's seat. You're not just a student anymore. You're the decision maker, the project manager, and the lead analyst, all rolled into one. We're going to tackle those complex cost estimation formulas and scenario-based analysis head-on, so you can walk into that exam room, or the boardroom for that matter, with total confidence. Let's do this.
Picture this for a second. You've just been handed the reins to a massive IT deployment. The stakeholders are circling, and they fire these three critical questions right at you. Are we spending too much? Are we late? And how much will this whole thing finally cost? These aren't just academic questions, right? They're the high-stakes reality of project management. To answer them, you need to rely on cold, hard data and rock-solid cost analysis. And that is exactly what we're going to master today.
Okay, here is our game plan for today. First, we'll cover the basics of project costs. Second, Scenario 1, estimating costs. Third, we'll break down the multi-factor ratio model. Fourth, Scenario 2, tracking costs. And finally, we'll wrap up with earned value analysis metrics. All right, let's jump right into Section 1, the basics of project costs.
Before we can even think about calculating a budget, we need to know what actually goes into it, right? Every single dollar you spend on a project is going to fall into one of these four fundamental categories. First, we have direct costs. These are the tangible things directly tied to your project's execution. Think hardware, software, and licenses. Next, indirect costs. These support the project but aren't tied to a specific deliverable. You know, things like office electricity, admin expenses, or training your team. Then, there are opportunity costs. This is literally the value of the next best project you didn't choose because your resources are tied up here. And finally, risk-related costs. These are your safety nets, like contingency reserves or insurance, to help mitigate potential disasters.
So once you add up all those planned costs, you establish what's called your cost baseline. Now, this is absolutely crucial. This baseline is your ultimate measuring stick. It's fixed, it's time-phased, and, pay attention to this, it excludes management reserves. Throughout the entire lifespan of your project, you're going to constantly compare your actual spending against this very baseline to figure out if you're financially healthy or, well, bleeding cash.
Moving on to Section 2, Scenario 1, estimating costs. Let's leverage some historical data to build a brand new project budget. Take a look at this data table. Back in 2022, our historical baseline project cost $240,000. It had 20,000 lines of code, medium complexity, and moderate team experience. Before a new 2025 project, the size jumps up to 28,000 lines of code. The complexity shifts to high, but thankfully, our team experience is also high. So, here is your classic exam question. Based on this, what is the estimated cost of the new project? To solve this, we'll use Section 3, the multi-factor ratio model. This is essentially a structured cost model used to scale our old costs using specific multipliers. To crack this model, we just need to calculate three distinct factors. Step 1 is the size factor. Step 2 is the complexity factor. And Step 3 is the team experience factor. We're going to calculate each one and then multiply them all by our historical cost. So, let's do the math. Step 1. The logic for the size factor is beautifully simple. We just take the new project size and divide it by the old project size. That's 28,000 divided by 20,000, which gives us a size factor of 1.4. In other words, the new project is exactly 1.4 times larger than the old one. Make sense? All right, Step 1 is in the bag. Moving right along to Step 2, we need to assign our complexity factor. According to our scenario data, the new project has a high complexity rating. Based on standard cost evaluation tables, a high complexity assigns a factor of 1.25. Basically, because the project is tougher, it's going to drive our costs up by 25%. Finally, Step 3, we need to account for our team. Our new project features a team with a high experience level. And guys, this brilliantly illustrates why investing in your people really pays off. A highly experienced team is way more efficient, which actually lowers our multiplier down to 0.85. Now we bring the whole shebang together for the final answer. The formula just takes that old cost and multiplies it by our three new factors. So, we take our historical cost of $240,000, multiply it by our size factor of 1.4, multiply that by our complexity factor of 1.25, and finally multiply it by our team experience factor of 0.85. Run those numbers and boom, you have your mathematically sound estimate for the new project. Fantastic job estimating! But now let's look at Section 4, Scenario 2, tracking costs.
The project has started, and we need to diagnose an ongoing project that might literally be heading straight for a ditch. Before we look at the actual numbers, though, I need to warn you about a classic exam trap, confusing planned value with earned value. You absolutely have to know the difference. Planned value, or PV, is the budgeted cost for the work you planned to get done by today. Earned value, EV, is the budgeted cost for the work you actually completed by today. As we all know, reality rarely matches the plan, so these two numbers are almost always going to be very different.
Okay, let's look at the data for scenario 2. Our budget at completion, which is just the total approved budget, is $100,000. Now, at this specific point in time, our project plan says we should be at 50% completion. However, in reality, our actual work completion is only sitting at 45%. And to make matters worse, our actual money spent, known as actual cost or AC, is already up to $55,000. So we've spent a lot, but we haven't actually finished what we promised. Just how bad is it?
To find out, we need Section 5, Earned Value Analysis Metrics.
It's time to diagnose this project by crunching PV, EV, and our performance indices. First up is calculating our planned value. The formula here is our budget at completion multiplied by our planned work completion percentage. So $100,000 multiplied by 50% gives us a planned value of $50,000. According to our schedule, we plan to have produced $50,000 worth of value by today.
Now, let's calculate the real story, earned value. The formula is our budget at completion multiplied by our actual work completion percentage. So we multiply our $100,000 budget by our 45% actual completion rate. That gives us an earned value of $45,000. We planned for 50, but we only earned 45. Yikes! So let's see how this builds into our absolutely most critical metric, the Cost Performance Index, or CPI. This little number tells us our exact cost efficiency. The formula is simply earned value divided by actual cost. So we take our $45,000 of earned value and divide it by the $55,000 we actually spent. That calculation leaves us with a CPI of 0.82. Let's map this math directly back to reality for a second. A CPI under 1.0 means you are over budget. Bluntly speaking, a CPI of 0.82 means that for every single dollar this project manager is spending, they are only generating 82 cents of actual project value. The project is quite literally burning money. But wait, it actually gets worse. Let's quickly run the Schedule Performance Index, or SPI, just to check our timeline. The formula here is earned value divided by planned value. That's 45,000 divided by 50,000, which gives us 0.9. Just like with CPI, an SPI under 1.0 is bad news. Coming in at 0.9 proves that this project isn't just over budget, it is also undeniably behind schedule.
And there you have it. You've successfully navigated estimating a new budget and diagnosing a failing one. You are officially prepped for these cost analysis scenarios. But I want to leave you with a final thought to take away from this explainer today. The math? Well, that's really only half the battle. Now that you know how to calculate a devastating CPI of 0.82, I challenge you, take off your math hat and put on your project manager hat. The data is telling you this project is bleeding. So as the decision maker, what's your next move to fix it? Keep that question in mind as you prep for finals, and I will catch you in the next explainer.